The diagram shows a solid in the shape of a half cylinder. The diameter is 7 and the height is 16. Calculate the volume of the solid. 2 marks. Cylinder has the same formula as a prism. In other words, it's always your flat surface area, which in this case, if you think about it, is just a semicircle, right? Then multiply by your height. Okay, so it doesn't matter whether it's a cylinder, it's a triangular prism. Technically, they have the same formula. So volume of solid is just equal to half times pi times radius. What's the radius? They give you diameter, so radius is 7, radius is 3.5. Square times your height, 16. That's it. Then press your calculator. I will always leave the answer in terms of pi first. So I have 98 pi, which will give me 308 in 3SF. For EMAF, normally we leave it in 3SF. You want to leave it in terms of pi, it is acceptable. But normally in EMAF, we don't leave it in terms of pi, we just leave it in 3SF. If you take AMAF, then normally you will leave it in terms of pi. That's why Cambridge will accept both. Huh? You want to leave in pi, it's acceptable. All right, but normally we'll multiply out for EMAF. Having said that, if you need to use the volume later on, you should use back 98 pi. That's why I leave it in terms of pi, so that if I need the exact value later on, I can use the exact value. Calculate the total surface area of the solid. So you should recognize that your total surface area consists of 2 semicircles, which is 1 circle. Then the curved surface area plus the flat rectangle. Remember to add back the rectangle, please. So how to find the curved surface area? In a normal cylinder, the curved surface area is a circumference times height, right? In a half a cylinder, it's the same thing. It's the circumference of the semicircle. So you just take your circumference divided by 2 and then times height. That's it. Okay? And you realize this question is 3 marks, but they barely give you any space. Cambridge is telling you it's 3 marks, but it's very easy. Don't even need space to do. So total surface area, add up the 3 parts, or rather, yeah, technically 3 parts. You have pi r squared. Why pi r squared? 2 semicircles will give me 1 full circle. Don't need to go and do extra work, please. Then plus 7 times 16, right? That is your rectangle. Then plus pi times diameter times half, because it's half of a circle. It is just a semicircle. Then this one you times the height, which is 16. Okay, that's why they give you so little space, because you can just squeeze everything together. Okay, if you cannot visualize, this is your 2 blue part. Then this is your yellow part, right? The rectangle. This is the yellow part. And lastly, your curve part. Your curve part is here, right? And then I color the whole thing and you cannot see anything already. Very good. Okay. The arc of the semicircle multiplied by the height will give you the curved surface area. Okay. Again, I will normally leave the answer in terms of pi first. If I leave in terms of pi, I cannot do that. So I have 7 times 8, which is 68.25 pi plus 7 times 16 is 112. Then from here, then I press the calculator. 326 in 3 SF. Okay. The reason why I leave it in terms of pi in part step 2 is just in case I need it later on. B is relevant to the N-level students too. In your syllabus, you don't need to know how to prove congruency and similarity, but you need to know how to apply congruency and similarity. So this is your similar figure property. So they tell you that the ratio of volume of cone A to cone B to cone C is 1 to 3 to 8. Find the ratio of the height of cone A to cone C. Zachary, what do I need to do? Height of cone A to cone C is equal to what? They give me the volume ratio, so I need to cube root. So cube root 1, right? Cube root to cube root C is 8, right? And therefore you get 1 to 2. Okay, very straightforward. Find the surface area of cone B as a percentage of the surface area of cone C. This one, be very careful. B to C, they give me volume of cone B to cone C. So volume cone B to cone C is 3 to 8, correct? You cannot find area scale directly. You need to go and find linear. So linear can be anything, for example, height. So height B to C will be cube root of 3 to cube root of 8. And you should recognize that cube root of 3 is not going to give you a nice number. You can just leave it as cube root 3, or you can leave it as 5SF, up to you. Okay? If you want, you can leave it as 5SF. You give me 1.44, 2, 2, 2, 2. That is your height scale. And therefore, your area scale for B to C, you will have to take this 1.4422, you have to square it. You have to take the 2 here, you have to square it. So you will get 2.079924. Okay. This is 5SF. This is 5SF. So there is no shortcut here. You take your volume scale, you cube root it to go and find your linear scale first. Then from your linear scale, then you square it to find your area scale. Don't get that mixed up. So this will give you surface area of B as a percentage of surface area of C will just give you 2.0799 out of 4 times 100%. You will get 52.0% in 3SF. Okay? Yes. It also works, if you if you get an exact number, you can don't put the 0.0 it's fine. Based on your method, you don't get a 0.0, right? You get an exact value, right? 52, right? Then you just write 52 . The exam question does not expect you to work in certs, So most students, if you are E-math, you would actually go and find the numerical value. But if you didn't use the numerical value, you use the exact value, right? You would have found the answer is exactly 52%. But Cambridge will accept 52, accept 52.0. They won't penalize you for this kind of thing one. Because you are not expected to be able to use the exact value. Okay? Let's move on.